solving radical equations that have just a single radical expression in them. Okay, so the steps are the same with multiple radicals, but I want to break them down into two separate types. All right, so when you approach a problem that's asking you to solve for an equation that has a radical in it, okay, the first thing that you're going to look to do is isolate that radical. Okay, so you're going to take that whole radical expression, get it completely alone, even if it's a variable that you're moving to the other side. When I add an x to both sides here, I'm just going to reorder my terms, x plus 2. Again, it doesn't really matter here, but just to stay consistent. All right, once you isolate the radical, what you're going to look to do next is undo that radical. So in this particular case, we're going to undo a square root by the reciprocal operation, which is squaring both sides of the equation. And now, when you square both sides of the equation, notice what happens. On the left side, it simply cancels with the radical. So you've now eliminated the radical from your equation. On the right side, the common mistake is to forget how you distribute through terms on a binomial square. And remember, you do have to account for the outer and inner product. So we take the first term and square it. We double the products of the two terms. So x times 2 is 2x. We double that, we get plus 4x. And then we square the last term, plus 4. Okay, so make sure that you do that step. Otherwise, you're not going to have the right terms. But once you do, you're just going to solve the resulting equation. So notice in this particular case, the resulting equation is a quadratic that has multiple variable terms. If that's the case, we isolate all the variable terms, or all the terms on one side and set it equal to 0. So we have our x squared. We're going to move the x's over to the right as well. So we get plus 2x. We're going to move our constants over to the right as well. We get negative 3, and that's all set equal to 0. So when you solve this resulting equation, whatever it happens to be, follow your rules for solving that type of equation. So in a quadratic, we're going to look to see, can we find factors? Our first terms are x's. Are there two factors of negative 3 whose sum is positive 2? 3 and negative 1. So here's our potential x's, a negative 3 and a positive 1. Okay, now here's where it's very important. Okay, because it's not always required to do this step, but in all the cases of what I'm talking about today, it's going to be required that you check your solutions. Okay, so when we plug this back in, and let's say we test our negative 3, we get the square root of 2 times negative 3 is negative 6 plus 7 minus a negative 3 is equal to a 2. Well, what do we see happens here? Is 1 plus 3 equal to 2? No. So this is an extraneous solution. So negative 3 does not work based on the restrictions of the original problem. Okay, let's test for 1. When we test for 1, we get 2 times 1, which is 2 plus 7, minus 1. Does that equal 2? Again, these are question marks here. Okay, so 2 plus 7 is 9. Is the square root of 9 minus 1 equal to 2? Yeah. So that one works. The only solution for this problem then would be 1. Okay, so make sure that you check your solutions.